I have your quiz to give back from last week. Again, I'll do that at the end. I have all of them. So we are going to continue from last time. We stopped at the midpoint. By the way, did anyone notice anything about this quiz? Circles in there, yeah, but that was in the bonus problem. So, something else? Anything else that stands out? Nothing stands out. The quiz always starts the same. Did you guys notice that?
Yeah.
Okay. So, some of you probably caught on to this a while ago. That has been the case for like the past 3 weeks. This is like the 4th quiz now, where problem 1 was exactly the same problem. I don't know if anyone realized that. Like exactly the same. Like I didn't move things around, didn't change notation, nothing. Like I had the quiz, and every time I'm writing a new quiz, I delete everything after problem 1, leaving problem 1 exactly the same, and I write the rest of the quiz. I've been doing that for like, this is the 4th time that's happening. I don't know if you guys have noticed that. No. Some of you have noticed. And probably while you're taking the quizzes, you're wondering to yourself, is Javon an idiot? Just like, isn't this the same problem he put on the quiz and the week before that? Last week's quiz was out of 10 points. Problem 1 was 6 of those points. And that was the 3rd time that problem showed up on a quiz. Some of you might be wondering, is he crazy? Is he senile? Did he forget that he asked us this? You're like, he's pretty much giving away free points. He's helping us cheat, essentially. Doesn't he realize that? Okay, so allow me to defend myself. Because, it's funny enough, people are still getting it wrong. This happens every week. Every single week. I ask the same problem. People would write the wrong answer or leave it blank. Every week, I would mark it wrong, and I would hand it back to them. Every week, I would post the answers to the quiz. So maybe they didn't know what the answer should look like. So I wrote out the answer, posted it online. Then every week, I give them the same problem 1 again, and every week, they get it wrong again. What's going on? Why would that happen? Why would that happen? I mean, after some point, it's not even about math anymore, because you could just like memorize the answers, not even know what they mean, and just copy it down. You're like, this has showed up so often, just by virtue of me viewing the answers so 4 times in a row, I kind of know what the answer is without even thinking about it. So we kind of had overlapping lectures. So what happened was the first time I repeated that problem, I was like, well, I kind of continued the lecture from here, so technically we discussed the same formulas between these 2 lectures. Some of these kids need a break. Let me throw them a bone, put the same problem, give them a chance to up their grade. And then they got it wrong again, which I was surprised by. But then I decided, I wonder how far I can push this. Then I started thinking to myself, I wonder if I put this a 3rd time, they're going to get it wrong. Like, no way. Definitely not. It's not going to happen. Right? And I have a friend who's also a teacher. He tends to be the pessimistic one. And he's like, he's always the one who's going to tell me, the students aren't going to catch on. I'm like, no, you're wrong. My students will catch on. So I put it on a 3rd time. Got it wrong again. I'm interested to see today's quiz. See how many people got problem 1 wrong. So, this is time for me to put on my Papa Jawan hat again and give you guys a lecture on life. You need to pay attention. Okay? That's it. A lot of you might think math is difficult, math is hard, you have math anxiety. Some of that comes from, your friends telling you how math is hard, and your parents telling you how math is hard, and everyone's like, oh, math, So you have some math anxiety from that. But for a lot of you, I would say for most people, the problem isn't really math. The problem is just don't pay enough attention. Right? You don't pick up on patterns. You don't, just don't pay attention. And the thing is, math kind of gets a bad rap because it's one of the few places where that has consequences. It comes back to bite you, right? See, most of the time you make a mistake in everyday life, there are big mistakes out there, yes. But most of the day-to-day mistakes you make, they're actually not a big deal, right? You recover from them and it doesn't even make a difference, okay? Get in an elevator, you meant to get off on the 6th floor, you accidentally get off on the 5th floor. It's not a big deal. You just wait for the elevator again, or you walk up the stairs, you get where you're going like 15 seconds later. Right? It's not a big deal, right? So the mistakes kind of correct themselves, and everything works itself out. In math, it's not that way, right? In math, when you make a mistake, boom, the consequence hits you, and so people just kind of take math as, math is so hard. It's not the math that's the problem. A lot of the time, it's what you're doing to make the mistake in the first place, and you not catching on to your mistakes, and that just repeating that cycle, that's the problem. Okay? To get that problem right requires no mathematical skill whatsoever, none. Right? Yet, week after week, I had the same problem. What's AQ minus BQ? People still don't know. Sometimes you guys say, man, this class is so hard, I'm studying hard for pre-calc, and you're like, oh yeah, what's AQ minus BQ? I don't know. A lot of you aren't studying as hard as you think you are, because the very basic things you're just not paying attention to. Now I'm wondering, if I put it on a 5th time, I'm kind of thinking, can I keep this one problem on every quiz for the rest of the semester? I wonder if by the end of the semester, everyone's going to get it right.
You should do it.
I should do it, right? Just as an experiment, I should. I'm going to do it. Now, had someone asked me to take a bet on that at the beginning of the semester, I would say, like, no way. Now I'm not so sure. Now I feel like I'm never going to get 100% on problem 1. I just don't know. I'm getting more and more pessimistic. Pay attention. You want to pick up on patterns. You see a squared minus b squared, there's an appropriate reaction to that. You're right, a minus b times a plus b. These are just, it's not a math thing. That's just an everyday life thing, right? You see a closed door, you want to go through the door, you open the door, you walk through it, right? You're driving, see a red light, let your foot off the gas, put it on the accelerator. There are some things that when you see something, there's an appropriate reaction that follows that. And it's not a math thing, it's just a matter of paying attention, you see that, do this. And that's essentially what problem 1 is, right? You see this, write down this. And it's not like you don't know what that is, because I write the answers down and post it online every week. If you guys don't believe me, go to the website, the class website. Every quiz since quiz 3, 4, 5, and 6 today, if you look on version A of all those quizzes, exactly the same problem 1. Look at version B, exactly the same problem. Go, look, if you don't believe me. Exactly, nothing has changed, not one thing. Guys, you need to learn to start paying attention. It's not good. Now, that being said, let us continue. So last time we derived the distance formula. We kind of rushed through the derivation of the midpoint formula, so let me just pick up there again. So let's talk about the midpoint really quick. I was kind of rushing to get out of class. So again, say we're on these axes. We have 2 points, x1, y1, and x2, y2. And there's a line connecting them. And I want to find the point that's directly in the middle, equidistant between these 2 points. That's the guy I want to find. That's called the midpoint. Let's call it x comma y here. Okay, so this is M, which is the midpoint. Okay. Last time what we saw was, the trick was we kind of created a big right triangle here, and then we cut it down with a vertical line like that. This created similar triangles, and we know that similar triangles are proportional. So the length of this side is the same as the length of that side. And it would also make sense that if you were to cut this again, the length of this is equal to the length of that. And since these 2 are the same, right, that cuts it halfway. It means that these 2 would have to be the same by similar triangles. And so what we look at is we realize that this distance here must be the same as this distance here. So 1 must be equal to 2, right? So we have 1 equals 2. Now if you want to actually measure that distance, let's do the horizontal distance first. Remember how you measure a horizontal distance? You take the right point minus the left point. And these are just 2 x values. So this is x, that is x1, and this will be x2. So for 1, that is going to be x minus x1. And for 2, that's going to be x2 minus x. So we end up with that being the same. What we can do now, bring the x over here, 2x, bring the x1 over there, and then we divide by 2. Right? So that tells you the x-coordinate for the midpoint. Similarly, right, by doing the same kind of manipulation with these, the vertical lengths, we can show that similarly, the y-coordinate of the midpoint would be given by y1 plus y2 all over 2. So we knew this since last week, but we kind of just rushed through this thing here. So this implies that the midpoint between x1, y1, and x2, y2 is given by, let's call it m, x1 plus x2 all over 2, comma y1 plus y2 all over 2. And that's the midpoint formula. So you don't need to know how to derive it, but you do need to know that formula, because I might ask you and you might need to use it. And you might also recall last time we looked at the distance formula. So the distance between these 2 points, d, was given by the square root of x2 minus x1 squared plus y2 minus y1 squared. It is also worth mentioning that the order actually doesn't matter here because we're squaring, but the way we derived it, how we thought about it using Pythagoras' theorem, just ends up with the x2 being first and the y2 being first. So that is the distance one. So we sort of ended last class having derived those 2. Let's actually do an example here, which is similar to the bonus. There was a bonus problem on your quiz that sort of spoke about this example. I'll give you 2 other points. Minus 1, 2, 7, 4. These are 2 points in the plane. Find the distance between them. And B, the midpoint between them. So nothing too complicated here. We're just simply going to plug these guys into this formula. We can label the points any way we want. So let me just label this x1, y1, x2, y2. And so my d here is going to be the square root of. And until you have a formula kind of burnt into your brain to the point where you can't forget it, even if you're half asleep, keep copying down the formula until you remember it. So now I'm going to just plug these numbers in. So x2 minus x1 plus y2 minus y1. So this is the square root of 8 squared plus 2 squared. So that's 8 squared is 64 plus 4, so this is the square root of 68. Which you could reduce, but whatever. Similarly, b, if you wanted to find the midpoint, that's going to be x1 plus x2 all over 2, y1 plus y2 all over 2. This is going to be minus 1 plus 7 all over 2, comma 2 plus 4 all over 2. So that's just going to give you 3. And this would give you also 3. So what we've just found, and this will come in handy a little bit later when we're talking about circles. Which I can probably actually maybe talk about right after this. Kind of going out of order of the textbook, but maybe I can. Probably shouldn't be too much harm. So what we're actually saying here is, let's say we're on the axes like this, and we have minus 1, comma 2, so that's over here, and we have 7, comma 4, that's over here, and you connect those with a line, then what we're saying is the length of that line is going to be square root of 68, and the point in the middle of that line is going to be 3, comma 3. So this would be at 3, and that would be at 3. So that's kind of graphically what's going on. So distance formula and midpoint formula are important formulas, and one reason why they're important is because we can talk about an object called a circle, which is a very common object to come up in a mathematical context. So let's just deal with circles right now. Definition: a circle is the set of all points in the plane equidistant from a given point. So the idea is so here we have some given point in the plane. And I want to find all points that are a specified distance from that point. Okay? So let's say I measure a distance here. Let me call that R to be very suggestive. And that measures to another point here. But I also want to measure that same distance in all directions. That's kind of not to scale, but the idea is you're going to have something like this be created. where you're always having the same distance here, right? And all these points here along the edge, they're the same distance from that given point. And so if I take all of these points, this forms a circle. Right, so this is called a circle. That's what a circle is. Set of all points that are equidistant from some given point. Now, some definitions right away. What we call the given point here is the center of the circle. And the common distance r is the radius of the circle. So those are the names we give to these quantities. And so now the circle is all points x comma y. Right? So where xy represents an arbitrary point on the edge here. Find all such points and you would have found what we call a circle. So now let's actually figure out what the equation of a circle is. How can you describe the relationship between all such points? So, say the center is this coordinate, h comma k. That's just a notational thing, very common. And the radius is r, and points on the circle is r x comma y, where these guys are variables, they can take on values along the edge. Then that means the distance between hk and any xy is the same. That's what makes it a circle, namely r. So now we can apply the distance formula. This means by the distance formula, r is the square root of, let's look at this as x2, y2, and that's x1, y1. So that's x2 minus x1 plus y2 minus y1. I'm calling this original point x1, y1. Call this x2, y2, and apply the distance formula. I get that. Or in other words, to rewrite this without the square root, I can square both sides. Obtain this equation. Now this is the equation of the circle with radius r and center h comma k. And so now that's the formula that you have to remember. So whenever you are looking for a circle, or you know something involves a circle, you're looking at something with that kind of equation. Questions at this point? Let's actually find some circles. Now it's worth mentioning sometimes this is written in expanded form. Right? So here, x minus h squared, that's something you can FOIL and multiply out, you can expand. Same thing with this. So this guy would become like x squared minus 2xh plus h squared, y squared minus 2yk plus k squared, etc. So you can FOIL it out, kind of regroup, and write it in a form like x squared plus y squared plus ax plus by equals. Okay. That's an expanded form. And usually if it's given to us in this form, we kind of want to rewrite it in that form. Properly identify the circle. Because usually if you have it in this form, it's very easy to draw a picture of the circle. You'll just pinpoint this coordinate and you can measure a distance r and you just do everything equidistant. You can know exactly what the circle looks like. It's a little bit harder when something is given in this form. And the question is, how we would rewrite them is often via completing the square. So here we're going to talk about completing the square again. So sometimes we're given a circle in this form, we need to identify the circle properly, and we can do so by completing the square. And after that I'll do a problem like what was on the bonus quiz, where given 2 points on a circle, we can actually find the equation of the circle. So here are some examples we're going to do. Find the center and radius of the circles. We'll do another example after that. But for now, let's find the center and radius. Radii. A. What's A? Center is, what did you say?
1 negative 2.
1 negative 2. Radius?
2.
So 2. Now the idea here is you have to pretty much rewrite, think of it in the general form of a circle. Notice that this guy we can think of as x minus 1 squared plus y minus a minus 2 squared equals 2 squared. So 1 here is the h, minus 2 is the k, and 2 is the r. Okay, so that matches up with the template of the equation of a circle. So that one was already written in a pretty nice form, so we can identify those points pretty easily. What about B? What? Come again? The center is 0, 0. And the radius? Square root of 3. So you look at B. X squared plus y squared equals 3. And we are going to think of this as, well, x squared is x minus 0 squared. Y squared is the same as y minus 0 squared. And 3 is the same as square root of 3 squared. So that's my h, my k, and my r. So those are not so bad. Those are pretty easy. That's just to get you used to the form. Pretty much never going to ask you to do one of those. Chances are, if a problem like this shows up on a quiz or a test, it's going to be like one of these. Let's actually look at how to deal with those. So C. Now we've actually discussed completing the square before a little bit. So let's actually just jump into this. Okay, so what would you do here? Yep.
So you put the x's together and the y's together.
Okay, yeah, first start to organize things a little bit here. Again, that's probably another one of those things that people don't mention a lot. Especially if you assume you're not someone who's very good at math. There's a lot of things that go into becoming better at math. And so that aren't normally mentioned in a math class. One was paying attention, just that, paying attention and picking up on patterns. 2 is being organized. You always want to have some sort of structure to things. Right? So before you start doing anything, try to organize things, group things, like things together, that sort of thing. Making things organized and neat will actually go a long way into actually improving your math skills. 2 is language is actually pretty important, which a lot of people don't think about. So definition, how someone phrases something, how you say something, the vocabulary that go along with math. You start paying attention to those things. These are some of the things that will help you get better. That is often overlooked. Anyway, moving on. Reorganize group the x's and y's. What would be the next step?
You add the, I think 1 on both sides for the x, complete the square for that, and add 4 on both sides for the y.
Yeah, but what would you add?
1 and 4.
Why?
So you can complete the square.
Yes, but why 1? How do you know 1 is what you need to add for the x?
So when you factor, you get x minus 1 squared. And then if you add the 4, then you get y plus 2 squared. I don't know how to explain it, but do you get what I'm saying, sort of? Or
well, I know what you're saying, but I want to know why. Let's say we're not all as smart as you and you can see it. What if this was radical 17? What would you add to both sides? Okay, so that's the problem. That's what I'm trying to get at. Why do you add 1? Yeah, Mary.
You do -2 divided by 2. You do -2 divided by 2 and then square the number.
Okay, so remember we actually discussed this before. The constant you want to add is going to be half the coefficient of x squared. So what you're going to do is you want to add -2 over 2 squared. That's why it's 1. That's why you're adding 1, right? There should be no guess as to what number you have to add. There's a formula that tells you what number to add. You are going to take half the coefficient of x, you're going to square that, you're going to add it, right? There are, I like to do it this way. You could add this to both sides to an equation, that's valid. personally I like to do this, and I'll kind of add and subtract in one swoop. I'll kind of explain why I prefer that way, but I mean, it's not a hard recommendation. You don't have to do that. Know how to add to both sides. But actually, example D will show you why I kind of like doing it this way. So you add and subtract 1/2 of that square. Similarly, I am going to add and subtract 1/2 of this square. And equals -1 over here. Now, once you do that, the first 3 terms always become a complete square. So these guys, it's going to become x plus the guy inside the parentheses, which is now -1, all squared. That's going to become this part. I would be left over with the -1 from here, plus y plus the guy on the inside, 4 divided by 2 is 2 squared. That will be that double underlined part. And then I'd be left with -4 from this guy that's left over here. That's equal to -1. Now, as you can see, I would add these to both sides, so you could have added them to both sides here. I like to add and subtract for, again, I'm going to show you in example D why I kind of like to add and subtract. As long as you're accounting for it, I don't particularly care how you do it. Okay. So now, I will leave these guys on the left, bring those green numbers over on the right. And so I'd end up with 4 of them. Now, coincidentally, that happens to be the first guy, and so at this point we can know that the center is 1, -2, radius is 2, right? So this guy and this guy were actually the same. This is just an expanded form of that, right? But it's good that you can now go from something like this to a nicer form. So that would be the center and radius here. Any questions on this? Okay, so again, what you're adding is 1/2 of this square. So in that question that I asked earlier, what if it was radical 17 here? You take radical 17 over 2, you'd square that. You'd add 17 over 4 to both sides. Or add and subtract 17. Let's actually do D. Okay, so we might decide to start doing the same thing here. 2x squared, 6x, 2y squared, 10y plus 9 equals 0. Okay, what would we do now? Huh? Sure, you can do that. Now what? Yeah, Miriam.
What do we factor out 2?
Can factor out 2, right? So remember, our rules for completing the square only work when the coefficient of the x squared was 1. So that would probably be the next step. And now what you would do is you would complete the square inside the parentheses. Okay, so how would this work? What would I add in? What would I add? Maybe add to both sides. What would I do here? Yeah.
I think you would subtract 4.
Subtract 4. Why?
Or you will multiply by 4.
Multiply the whole equation by 4?
No. On the other side. You see where the -9 is?
Yeah.
You would multiply by 4. Or
Okay.
you either multiply or you either
Why
multiply
by
or
4?
I don't know. I think I saw it in the textbook.
Okay. We need to know why we're doing what we're doing. That's not. Yeah.
What do you do completing the square on the inside?
Come again?
What do you do complete the square?
Yeah. So what would we do? Right. Now completing the square involves adding a constant that makes the fixes the pattern. So.
So you have b in the square.
Come again?
You have b in the square.
Right. You have this and then you square it and then you add it. Right. So how would I apply that?
So -3 half square.
Yeah. Where does that go?
You add
So 2. What else? Just tell me what to write. I'll follow it.
x squared minus 3 plus -3 half square.
And do what?
Wouldn't you do the same for the other side? For the 1?
So the other side, you mean over here where the -9 is?
No, the 1. Wouldn't you have -5 in the square?
-5 over 2 squared. And then?
You have to add it to the -9.
You have to add where?
The -9.
What am I adding to the -9?
2 terms that you're adding.
-3 over 2 squared and then -5 over 2 squared times -5 over 2 squared. So you add that
So
to
you have -9, you're going to add
-3 over 2 squared times -5 over 2 squared.
times.
I think I have to multiply by the 2.
Add, okay, you add, and
Like that? Okay, so that's incorrect.
multiply the 9 instead.
No, you're not supposed to be multiplying. You're definitely adding something, but not those. Yeah.
Okay, I think you have to subtract 4 on both sides. Wait, no, subtract -9, 4 from -9, right? And then you have to multiply by, because I know you have to do something with the 2 in the front. It doesn't stay there. You have to like either multiply it by the other side or subtract it from the other side. I just don't remember. I don't remember, but.
So this is why I like the adding and subtracting trick, because then I never have to remember what I have to do. Turns out what you have to do to actually fix this is the coefficient here needs to multiply these guys here. But as we've just demonstrated, most of you don't remember. I know I have to multiply something, but I don't really, maybe it's this and that. Okay, if you do the adding and subtracting maneuver, you never have to remember that. It's not in the thought process anymore. So this would be fine. You could just remember that whatever you add inside here and you add it to the other side, you have to multiply by the coefficients. Okay? Now, why is that? Well, if you do mind trick where you add and subtract, you'll see why it had to be that way. Right? And this is kind of why I like, because I don't want to ever be in a situation where I'm not sure, I want to be sure every step of the way. I know what I'm doing. This is correct, this is correct, this is correct. Step 1 leads to step 2, leads to step 3, leads to step 4. And so I kind of like to think about doing problems in a way where I won't have to worry about remembering something that I can't really see. You know? You know what I'm trying to say? Because for some people it would be hard to see that you had to multiply those by 2 because it's just not there. However, if you were to do this trick, and go like, where's my green? Okay. Add 3 over 2 squared, subtract 3 over 2 squared inside the parentheses, plus add minus 5 over 2 squared, subtract minus 5 over 2 squared equals minus 9. Notice what's going to happen here. Do you see what's going to happen? Well, these first 3 will become a complete square, right? And then I'm going to have these guys left over. Now what's going to happen with those guys? I'm going to expand the brackets by multiplying by 2. Then I'm going to move them to the other side. So the multiplication by 2 happens naturally. I never have to remember, oh yeah, I have to multiply by 2. So what happens now, let's just write that, is that inside the parentheses, this becomes x minus 3 over 2 all squared. That is this. I would have that minus 3 over 2 squared plus x minus 5 over 2 all squared. That's that guy. And I'm left over with this minus 5 over 2 squared. Then, what I'm going to do now is expand the parentheses. Equals minus 9, kind of running out of space here. And now what I would do is move these guys to the other side. And so you see, the 2 kind of ends up there without me having to remember to put it there. Okay. So if you like the adding to both sides maneuver, it's fine. You just need to remember, multiply it by the coefficient of what's in front of the thing. However, if you do the add and subtracting version, you never have to remember to do this. It'll naturally end up in the situation where you end up multiplying. Now we can simplify a little bit. At this point, we're just kind of cleaning things up. This is minus 9. This will be 9 over 4 times 2. So that's 9 over 2. This will be 25 over 4 times 2. That's 25 over 2. So minus 9 plus 9 over 2 is minus 9 over 2 plus 25 over 2. And minus 9 over 2 plus 25 over 2 is what? What are these things? 16 over 2. So that's 8. And now what I can do is I can divide both sides by 2. That's going to give me x minus 3 over 2 squared plus y minus 5 over 2 squared equals 8 divided by 2. 4. So this one cleaned up nicely. Hopefully now you can actually see what the center and the radius are. center is 3 over 2, comma 5 over 2, and the radius. So, in general, the rule of thumb is every time you do something, you have to know exactly why you're doing it. You say, I'm going to add this to both sides. You need to know exactly why. You have to add that specific number to both sides. And in general, what you want to do is you want to come up with a way that you'll always remember the right thing to do without having to worry about it. And so I like doing it this way because I'll never forget that I have to multiply by 2. Now, some people, if they're in a test and they're anxious and they're rushing, they might forget that little thing. I'd never forget that little thing, no matter how anxious I am, because it's just a matter of distributive law. It's going to end up there anyway. If you can remember another nice way of doing that, in such a way that you'll never forget that you have to do it, then by all means. But this one reduces to that, and that's the equation of the circle. Let's look at another example. Any questions here? Because this one's kind of, yeah.
I get lost at the part where it says -9 plus 9 over 2 plus 25 over 2.
You're good with everything up to that.
Up to that point.
Okay.
Because
So,
under it says 25 over 2, -9 over 2 plus 25 over 2. How did you get there from where you were before?
well, common denominator, multiply by 2 over 2. It's one way to think about it. Another way to think about it
Okay.
is it's like I have -1 something plus a half of that thing. I'd end up with minus a half of that thing.
I got you.
That's kind of how I think about it, but you can do the common denominator thing, that's all I did. So -9, you can think of -18 over 2, plus 9 over 2 gives you -9 over 2, and then one other example I want to do with circles, which was kind of like the bonus on the quizzes. Find the center and radius of the circle that has, maybe let me pick 2 points from one of the quizzes. Okay. So let me pick the 2 points from quiz version A. It'll be different from version B. But let's say I told you there is a circle that has the coordinates -5, 4, -4, and 3, -6. As endpoints of its diameter. What does that mean? How would you deal with that situation? Yeah.
Find the midpoint.
Come again?
Find the midpoint.
Find the midpoint. Why would you find the midpoint?
Center. What is this?
So the idea is here, see why you would need to find the midpoint as he says. Here's kind of what's going on. So there's a circle. And say here we know the diameter. Well, it's actually going to look slightly different. -5, -4, 3, -6. So it's probably going to look more like this. So we have this point here is -5, -4, and this point along here is 3, -6. Okay. So you know the circle behaves like that. This is going along the diameter. What you should remember about a circle is the diameter will pass through the center, and the center will be the midpoint of the diameter. So that's why I said we should find the midpoint, because finding that is going to give us the center of the circle. So in other words, h comma k here is the midpoint. So that's the first thing I would find. Let's actually find that. So h comma k is going to be x1 plus x2 over 2 comma y1 plus y2 over 2, right? Which in an earlier part of the quiz I had you find the midpoint. So you would have had this as a part of a previous answer. So here I would have x1 plus x2 all over 2 comma y1 plus y2 all over 2. So your h comma k will actually be, this is minus 2 over 2, so that's minus 1. This is minus 10 over 2, that's minus 5. So that's actually the center. How would you go about finding the radius? Yeah? You go.
It would be the distance of the midpoint to, where those two points.
Right. The radius is just going to be the distance here. It's also going to be the distance here. So you pick which one you want to find. Let's just pick this one, for example. So let's use this one. So the radius is going to be the distance between what I just found for hk and 3 minus 6. So in other words, it's going to be the distance between minus 1 comma minus 5 and 3 comma minus 6. In the quiz, I had you find the distance between these two. In the event that you had that answer, all you had to do was divide that by 2, and that would be the radius. Okay? But with this, you can either find the distance between these two and cut it in, take a half of that, or find the distance between the center and so that's going to be the square root x2 minus x1 plus y2 minus y1. So you'll have that. So that's 4 squared, that's 16, plus this will be 1. So square root of 17 is going to be the radius. That's the center. Now, if I ask you for the equation of this circle, I mean, this question didn't ask you, but just see. FYI, the equation of this circle would be, well, what would it be?
X plus 1 squared plus x plus y plus 5 squared equals 17.
Well, 17. Right, the picture would look somewhat like that. I mean, the x and y axis would be like somewhere over here, kind of. Possibly over here. Somewhere over here. Not draw the scale. Pretty much all I want to talk about circles at the moment.
Are you moving ahead to something else? There was a question I had based on the homework.
Okay, sure.
Jay, one of the problems it involves finding the equation but using the tangent of the circle.
Yeah, that's actually one of the questions.
Does anyone remember the specific question?
I can
I
remember
actually
what
opened it up right now, like it's right here.
Oh, okay, find the equation of the circle with the given conditions. The center is, well then, I'm gonna do his homework for him now. That's what we've come to. First of all, I give away 6 points on a quiz, now I'm doing people's homework for them.
I wouldn't have an issue if the homework wasn't due tonight.
Okay, so this is equation of circle. We have center 2 comma minus 10, and its tangent to x-axis. Anyone have an idea of how to do this one? Any ideas? Yeah?
The diameter is on the x-axis.
The point on the diameter is on the x-axis. Right, so what does tangent to mean? When I say something is tangent to, what does that mean?
It's touching the x-axis.
Not really, but I guess in this point that's how it would work out, right? So it's not exactly what it means, but it just means like it touches it at that one point in this case because of how the circle is shaped. So basically this means like if I plot the coordinate 2 comma minus 10, that's where the center is. A tangent is something that it means telling us that it's tangent to the x-axis. Tells us that that's how it's behaved, where it just touches the x-axis here.
So we get the radius from that point to the center.
Right, and what would that be here?
The point would be,
It's 10, right? The distance
Oh, right.
down is 10, it's right there.
yeah.
And so we get radius is 10, and now we know the center is 2 comma minus 10, which means the equation
Is x minus 2 squared plus y plus 10 squared equals 100.
Okay. This is an example of what I meant when I said earlier, vocabulary is important, right? See, all I needed to tell him was what the word tangent meant, and everything started to flow, right? The problem that you had here wasn't a math problem, it was a vocabulary problem. The fact that you didn't know what that word meant. Okay, so this is what I'm talking about. It's one of the things that people don't usually say when it comes to math class. People think of math as numbers and calculations, and a lot of it is language. A lot of it is just knowing the definition of terms, knowing what words mean. Vocabulary is a big part of math. Sometimes the difference between not knowing how to solve a problem and knowing how to solve the problem is defining the terms. You do that and then, oh yeah, now it's obvious. No, this is pretty nice. This is huge. Look at the size of it. Yeah, we'll stop there. We're still in 1.9.
Are we getting our quizzes back?
And I will give the quizzes back because we have a few minutes. But to jump into something else at this point, not very beneficial. Let me give the quizzes back and I will see you guys on Monday.
Touching the x-axis.